Nem húznám tovább az időt.
Well, I don't want to take up any more time. I'm Buherator. And I'd like to speak for 3/4 of an hour about the following. Basically, as we heard during the previous two presentations, most of the audience were here during Feri, András and Zoli's presentations, who spoke about how we can develop exploits. And the topic of my talk is how we can integrate these programs in a framework system, and what the benefit of a frame is, because it makes your job a lot easier in testing intrusions on a daily basis. Well, I saw the great speakers developing their own agenda, so this is my agenda. I'll give you a short introduction to the framework and POC exploit, Metasploit module, what the pitfalls are and why it makes sense to add them to Metasploit, and what should be borne in mind, and Metapreter and scripts I'll also describe because they are effective in the exploits. And as I've asked you, please install the VMs and boot them up. I wonder who's managed to so far, and please raise your hands if you'd like to. Thank you. And I'd also like to find out who's worked with the Metasploit framework system. Very good, thank you. And who has developed modules in it? Not so many people, but this is why we are here. The Metasploit project began in 2003, and not so long ago it's gone beyond the 10,000th revision. Those of you who know something about programming understand that this is a nice big number, and that's one of the biggest Ruby projects out there. It's one of the open source projects also, of the many, or of the few, backed up by hard cash, because Reprosy has purchased the code set earlier this year, and I'm not quite sure, but there's a real business backing them up, and the code is freely available, differently from other framework systems. It's an intrusion testing framework system, which can be extended using modules, and plugins will deal with modules, exploit modules to be exact. And there are payload modules as well, including the shellcodes, and there are encoders which transform the shellcodes in a way that they should be acceptable for the target system. There are auxiliary modules which cover everything else, and I think now they're obsolete. The NOP generators, these are already obsolete. I'll come back to this during my presentation. Since we're talking about a framework system, we're also talking about a development platform, because the framework system provides a set of valuable tools for exploit developers, which will make their work a lot easier on a daily basis, as you saw in the previous two presentations. MSF payload generator and the sharper generator functionality was certainly introduced to you, and the encoders, or for instance various exploit offset search Metasploit scripts. You must have run into them. Well, the occasion why I'm giving you this talk is at university I began to deal with the framework, and I developed my undergraduate thesis on this topic, and I found documentation, the user's guide, developer's guide, the latest release 3.4. This is still under construction, and they don't include a description of many pitfalls that are easy to fall into. And we'll see examples of that. The Metasploit guide was published in 2004, and what the heck? I won't believe it's been 6 years since. It's a long time. And the Metasploit course has been published, and this is a good source, but it doesn't include everything, and there's a mailing list. In the open source projects, what typically happens is that you have the hackers who know the code bit by bit, and then someone comes along to ask a question, and then they will send them walking. And in Metasploit that's not the case, but the framework mailing list is a good thing to subscribe to. And the by hackers for hackers is the subtitle of this manual. So the code itself will describe itself. You won't have to go through the manual, but you can check in this way. Ruby is a very friendly environment because it will teach you how to do what.
Who use the Metasploit framework system probably have already faced the system that you must load lots of modules, process those modules, so that the whole thing develops very slowly. My solution to this problem was that one should have not only one framework system but several. For example, if he wants to make a partition in a homogeneous network, then he should collect all the Unix component into a memory space, and then he could speed up his own work. Very important Unix type commands that can be issued. For example, we can delete all the RB extension files of the module libraries which we are not interested in. No exploit modules will be in the framework system, only the in-test modules. I'd like to add new exploits, and whenever they are ready, then I can copy them everywhere I wish. For example, it can be Oracle, Web, WLAN, whatever you want. Get this party started. I didn't want to talk too much about theoretical background, but let's move ahead. I start you the image that you try to install a kind of bloodsucker. There is no best, I don't know. My Windows is booting. No beast without cruelty. We work from the console. Lots of run files, runnable files. Please tell me if you can't see it. If you don't say a word, I assume that you can see it. I start the MSR console, and with this switch, I can actually filter out all these inconveniences, and the Metasploit also will use the inline support of its own operating system. And you can see that we have an easy FTP server. 2 is an old version. I don't know whoever develops such a software, because they are much better than this, out of this kind of software. Maybe it was just a kind of etude, simple exercise. You go to the small fish, and then you can see these ports again, where they are placed.
Akkor azt mondom, hogy ne nézzük először a keretrendszert, hanem nézzük meg magát a forráskódokat.
Let's take a look at the source code instead of the system. Each module has a kind of template according to which we should develop these things, kind of scheme.
Látszik az, hogy nagyjából hierarchiában
You can see the hierarchy of the modules. Within the module there are exploit modules and test modules, and the test modules should be replaced into Windows modules. I prepared a sample.rd. I got a simple exploit. I took away the superfluous parts and I added some personal information which may help me. Metasploit is not a system which is used for proof of concept codes. At least this is my opinion. The reason why I'm telling you this is that because we must specify the name of the exploit, the description, who did it, under what license, and so on and so forth. And whenever you find a bug in your program and would like to use the bug, then you are not really interested in the license of your exploits if you would like to publish it. So what is much more important and much more interesting, this payload part. In the payload part you may specify how much space we have for our run code in memory, for our payload code. There are exploits where there is very limited space, and then we should jump in and out, and as the real shell code is located within the memory. Petcar's parameter is even more important, which says for the framework system what are those characters which I wouldn't like to see in my output, either network or file output. Default is 0 byte, because most of the programs are really upset about 0 bytes. And then there are these Linux, Maxnox, and so on. Here I can specify the parameter for the encoder, which says that from the encoder which is used from the concrete exploit in order to code the shell codes. The situation is that most functions which are needed for put together complex exploits will ignore the basic setting of encoding, or there are byte sequences that are absolutely useless to encode, but there are certain byte sequences which should be omitted totally from the transmitted byte sequence. So for this reason, let me recommend to you that if you are in a situation that you must omit certain number of characters, you should only use bad cards. Alpha mixed, alpha upper mixed characters are there to convert the shellcode into uppercase letters or alphanumeric codes, but as you will see, it won't be valid for most part of the exploits during generation. We will attack a Windows platform. Target field will be, if we have different kinds of operating system to attack, then simpler defense, operation system with simpler defense require a fixed point, a memory address with a jump instruction, but it's different from operating system to operating system. The Metasploit framework system gives an opportunity to list all the type of operating systems that the exploit attacks. There is an English version of SP2 with an address. I don't know what it really covers. It is probably a jump instruction. If the jump address differs from the address to which we must jump with EIP, then we can say that this is the situation at XP, Linux 2008, we don't know. We can't do this, Unix, and so on. So there is a nice array in which we can list them. And this is where we give the return address, and I will show how we can access to the return address. Exploit parameters are very important, because the reason why we use a framework system, because we don't want all the occasions, the need to rewrite the shell code and the address that we would like to attend. So we would like to click instead of writing program lines. So I'm attacking .to post host, and then we have register options, listed values. Opt-R port for all remote exploit must be defined, which will specify that in the case of a remote exploit, we need a target port. In the case of an FTP server, it is 21. But we may define any other option like this, like something which is just taken out of thin air. And if we must enter an FTP server, then we use this username and this password with which we would like to enter. Auto-filter, I won't talk about it. Metaspoiler has an auto point feature, which scans an IP region. We fill the result into a database, and Metasploit should run all the network exploit for all the machines in the network. Autofilter attributes. Autofilter is the name, and this method will tell us that for a given target, for a given goal, which target should be used. The target is defined here, and this is what we won't touch now. But it might be interesting and dangerous at the same time. If somebody just jumps into it like a jack of all trades and wants to crack all the machines in the network, probably he will end up in a chat situation. Check command for the framework system. If an exploit module is loaded, then it checks if the target is vulnerable or not with a given level of vulnerability. For example, sees that the version number is under 170. Then it says it's vulnerable, otherwise it says it's not vulnerable and exploit will not run. What we are interested in very much is the exploit method, which we start the connect and close with the disconnect with some other commands here. We join the remote server and then we step away from the remote server. I will speak about Mixnet, and this is the mixin that I listed that we loaded in. This is an exploit module remotely used through TCP connection. If you take a look at the source code of this mixin should be imagined as program classes. And if we check the source code of this program class, then we will see that it is an automatically declared, has an automatically declared airport and air host, Metasploit data store elements, components. So we don't have to deal with it in the register options because air host is just simply required from the user. Let's move now to the essential part. I loaded down Milworm or exploit, a very ugly easy FTP exploit, which is post authentication DAC overflow, for which we should create a library or a directory, which I actually hide somewhere. The source I hid somewhere. At least somebody should find it. Even I myself couldn't find it. This is what original exploit looks like. XP Pro SP tested. There is a big shellcode inserted. The exploit writer told me that it will start the carkex and wants to count the number of bytes. Some variables are generated here. We get connected to the remote host. There is a kind of call from this remote device. We send payload. There is a NOP set, a NOP slide with 40 NOPs instructions, commands, assembly commands, and then we put it shellcode, and the return address. I've corrected this since my system didn't have the same return address where the exploit writer put it. EBP points at NOP-SLED. This is the what I call NOP-SLIDE, SLED, sledge, whatever. 74 T1, and so this is the address 91. Metasploit, it is written into a Metasploit module. How? Let's say we should copy this sample here. This is the name, eft.rb, and then we can say it's written by Buherator. We give it a description. In our original exploit, let's see, shellcode was 228 bytes, and let me be pessimistic, and this is the maximum amount. You can really measure it with the debugger, and then I'll say that bad characters are the 00 characters, and then there will be line break, both version of line break, 0 as 0D, and then we will see the rest.
És a visszatérés címet, igen.
And then I must set the return address. 77D4 something F, and lo and behold, this is what is written here. This option is just neglected. And let's see what we must do here. Let me just get ready and copy how it puts together payload. And I know that the length of the NOP sled or slide must be 40 bytes. It's a funny function on which the NOPs slide down. NOP sled, he calls it NOP sled, and said in Hungarian NOP csúszda, but it is slide, not sled. Sled is Sanko. And then NOP, the last NOP, and then I must. Why is it important to have more than 14 lengths? So instead of giving a value of 40 times, what does this NOP slide or NOP sled know or can perform? It is just a camera back there, or the real thing is that if we push through 40 such values in the network, then a strict IPS starts to cry, why there are so many NOPs, NOP bytes, because it looks like a NOP slide which is normally used in exploit. And its function calls an object generator module, which is equivalent to the instruction sequence as if we had done nothing. Yes, it changes the stack value, but then it changes the values of the register, but then it reloads them. And when an obsled runs, everything remains as it used to be, with the exception that we have a heap of garbage in our memory, heap of garbage bytes. An obsled. We're ready with this slide. What should be done with the shellcode? We like the Metasploit framework because if we try out the shellcodes and not even the 6 operates, and I always change the byte codes. In Metasploit, there is a very elegant way of handling it. Payload dot encoded can actually substitute this. For each and every exploit, I can choose a payload in the framework system, which will be my payload object, and if it's called with its encoded method, then it will return a string which will follow the bad car, which will exclude those bad car characters given there, and it will produce the shellcode without those bad car characters. And then the return address is a target, which we have defined. Target object red is stored in the red field, but x86 is used to convert this. Was there any intermission or any remark made? Please tell me if I should explain something. And the Ruby way of doing it is that first we set up an array from the string object, and then we call pack upon it. This is the packw procedure, which is included.
This won't be enough, not good enough for us. Why not? Because we're not quite sure whether that path is correctly set. And also, one of the features of the framework is that a payload is extended to a size that corresponds to the definition in the space. So it automatically generates a NOP slide, and then it inserts the shellcode of 228 bytes so that we get a sequence with that length. Now let's look at the original exploit, how good it was. NOP slide was 40, 228 was the length of the shellcode. So then we can say we can safely correct this to 168, making the NOP sled disappear from here, and then it's going to result in an equivalent code for us, as though we had left 228 here and disable NOPs had been added to the initialization of this module, because if it's set to that, then this framework insertion will not take place. All we need to do is that sock remote TCP mix-in generated this. That's a socket for the host defined under lhost, and we boot a payload into it, and then out of the socket we do get once. Sorry, we'll read something back, because a few servers want to be read afterwards from the TCP channel, and then we do disconnect. And no need for knob sled anymore. Please note that up here we defined lots of foolish things and there's lots of comments, but this code, as you can see in the exploit function, it's a bit friendlier than this. One more thing I've left out. I skipped the log on. Let me check how much time I have, Ferry. When do you want me to conclude? At 5:02. So let me check what we've left out. And here's our help. Thank you. So we need to log on, which is really simple to do. Practically the same series of instructions in the targeting default user, anonymous under target. So user anonymous, padam padam. Anonymous /n, that is, you send anonymous /n, and MKB is another command that has to be issued. It would be good. FTP client, a few of you have written an FTP client and an FTP server as well, haven't you? Because there are FTP servers out there in the world. So here's when mixin comes into play. And now let me show you another element just to give you a more complete picture. Mixinet in the framework system is like a module of modules which have implemented a kind of protocol at the server or client level. I'll give you examples. I've collected a few slides out of the Metasploit source code. Here's the mixin spont RB, and this is where all the mixins are defined for all framework systems. And up here you have the path to the file, just in case you want to know. And here TCP, UDP, DIP, SMTP, FTP, you name it. So it's all been written before us. Why should we make an effort? Why should we suffer in order to write it, even though it might be a simple protocol like FTP? So let's make a detour and come back. And I'm going to produce my prefab exploit. Take no offense, please, because it has all the refined features. I want to debug my own code on the fly. So MSF exploit remote FTP mixin. I've started this. And to what degree has the code changed? Connect, instead of that we say connect login FTP mixin. In combination with this we'll do the following. FTP mixin registers into the data store variants to be filled in FTP user. FTP pass are the two parameters which is compulsory for the user to fill in, and then the login will use the data to log on, and if it doesn't manage, then we'll get an error message. Now here's debug information. FTP mixin, it gives us this. Send CMB MKD. That's the command I want to issue, and let's use this as the command argument. It's practically the same as we saw before. So we have the payload, and here's the knob sled and the return address. So let's get detached from this, and slip 20 is for testing purposes. I'll take this out. Let's see if it works. Yes, FTP server is running, and I do use exploit test easy FTP. That's the name I gave it. Show options. This command will list the data store parameters to set. And I'm trying to highlight these lines. FTP pass, FTP user. That's out of FTP mixin. lhost is remote TCP host mixin. And here's the payload, which in our case won't work because I've already tried it. But the payload can also have parameters, as you will see. One thing that is certainly working, because I've tried that as well, is the running of the simple calculator. That's the basis for all proofs of concept. So I do exec set payload if you issue this command, and then you keep pushing tabs. Then the framework system is smart enough to list only the payloads. It's like a Unix add-on instruction on the MSF console. It will only list the payloads that in principle could fit the exploit-defined maximum space, maximum memory space. So if we have a payload of 1,000 bytes and then in exploit we defined it at 128 bytes, then it will not come up. So in this case I'm within the parameters, and let's make this Windows exec. Show options. Let's check things again. FTP user. Anonymous is going to let us in because it's configured like that. 56.3 is good because and then I want to run calculator exec. And let us pray everybody together so that the demo effect doesn't occur. Well, the exception is quite expected because the embedder is going to cause the server to hang up and it will not respond, and voila, lo and behold, we have the calculator. What's the benefit of reducing our exploit from a much bigger length to a small size? Then we can consider whether I can use a reverse shell payload or notepad exe instead of calculator exe. Not that it would make any extra sense. So we can start playing with it from this point forward. But moving on to more exciting subjects, I'm running out of time. So let me show you the exploit of a lot more exciting program. That's MaxDB, a database manager under SAP. That's a remote loophole which will skip the authentication. I wonder it's been patched. Pansir mentioned this, and also in the upcoming presentation you'll probably hear about this. Let's look at the source code because that's the most telling part. Well, obviously I've closed down the word processor, and I did that at the wrong time, wrong place. And here's the accounter program. Hands up, who knows what accounter is? Accounter. Those of you who attended the hacker conference, András Kabai had a great presentation about this. Accounter is a very small code snippet, 30-some bytes, which takes the process, and in the virtual memory area, it will crawl through that area and will look for typically 4 bytes occurring twice in sequence. And we can define this ahead of time. And then it will continue to run the code afterwards. What we can do, based on this, is that in a very narrow range exploit, we insert an accounter, and in some way we get the process memory area to run our process code, which will reside in the memory, and then before the shell byte, these 2 times 4 byte prefixes, these are the eggs, by the way, these are inserted, egg hunter will scan the memory and then stumble upon those two eggs. We need two to avoid the problem that, for instance, by accident we could pick a very frequent byte combination for an egg, and then it would come up every second sequence, and then it would run some foolish code. So the egg hunter is run, and with the overflow we take control. The egg hunter will start the scan, and then it will come upon the eggs, and then we can insert quite a long shell code as well. What you see here is again remote TCP exploit is what we are talking about, and there's a mix-in and also an egg hunter which will benefit us because IH stub, IH egg, we do that, and let's equate this generate egg hunter, and that's a method which will return two objects. First, the egg hunter code, and also the egg, which will have to be inserted in front of the shellcode. And you can see that after running this, if egg hunter finds the shellcode, then we have 800 bytes space for code, and we only need to avoid the 0 bytes. Disable NOPs. I will come back to this. Let's look at the shellcode and the packet to send. In this case, out of one packet, we can cause neighboring systems to crash, and Wireshark or any sniffing program, a protocol, a header, this could be any such thing. And of course we don't care the least bit. Of course the proof of concept exploit code is where I got this from. I copied it, and here's the return address. And then this is all generated for us, and then we'll add a 0 byte. Safe one, or safe, don't care about this for the time being, and then we need a NOPS thread, quasi. I did not subtract the end from the beginning. I wasn't that picky, and the payload length, the shellcode length, and the NOPS thread size should add up to 1003 bytes, if I did the calculation well. And obviously the author of the proof of concept retroactively subtracted 2 times 4 bytes, 8 bytes. That's the NOPS thread. I insert the payload here, 4 A's here. I didn't mean to do an APS version in here because these 4 bytes could occur in many places. Then NOPS thread, egg hunter here, and then some random string, 14,900 in length, run text alpha. That's a function here. It's a very dumb function. All it does is it generates random alphabetical characters, basically characters. Why did we need disable NOPs? The reason is that if the payloading code, if we got always 800 bytes, then we would not be effective at all. And in addition, there are 2 eggs, and the packet is a lot clearer in structure if we say we should only have the shellcode here. And what's the need for safe NOPs? This is not described on the web or in any documentation, but let me come back to egg hunters, because egg hunters will disregard the encoder that we could set with the payload, but the Betcar's value will be taken into account. So that's why I'm saying let's not set the encoder or say that I want only alphanumeric shellcode. You may want that, but you had better list manually or using Ruby tricks or the non-alphanumeric characters, and the framework will take care of generating the code inside rather than setting the alphanumeric criterion, and then exploit won't work because Egg Hunter will fill the text with non-printing characters. Safe is a similar category. And mobs in that case, encoder or bad cops, will both be disregarded. Windows FTP Salon 31 overflow module, which I have no idea what it does. I stole it from there and rewrote it somewhat. I didn't read a lot of it, and I left the comments in. And I'm telling it to try 100 times to produce an obsled, none of the bytes of which should agree with the bytes stored. And if this is unsuccessful, then I want an error message or throw an exception. This is a program technique matter. Just make sure you pay attention, because illegal characters within the framework are quite loosely managed. So if you generate an encoder or an Egg Hunter, you can expect that neither the Egg Hunter values nor the Batcast values will be taken into account. But in this way, the stuff is working fine. I tried it. We're running Egg Hunter, and just think about this. The process must call through the virtual memory area. In a virtual machine or in a weaker machine like mine, it will take a few seconds, even a few minutes. Because when we run exploit, a remote exploit in the framework system, what happens is that first the payload handler method is invoked, and then share with comments. In that case, it will mean that it will wait for something to join it, and that will be a separate thread within the Metasploit process, and then it will export the byte series, and the other side will wait until it is connected to something, but it won't wait infinitely until exploit has run. That's the exact point until which it will wait. That's my experience. And since it can take up to quite a few seconds, the Egg Hunter based exploits will get hold of the shell code and halt it, and this is why I put in some sleep. Exploit should not end by sending the packet, okay, I've disconnected, and that's it, goodbye. And payload must return and be found by Egg Hunter through a network connection, and it will have to come back to me, and from that point forward I can deal with it.
Took away a couple of hours from my life till I understood why my Encounter free exploiter didn't work, because the header wasn't alive yet. What can it done? Your time is up. Absolutely up.
Jó, akkor azt mondom, hogy
use exploit test SAP with max. I'd like to use maxdb. I must show the options. I always forget the options. It looks more friendly. Remote length, remote post is normally set. My own post is also normally set. Unfortunately, I don't have the time to speak about this. I say exploit and let's see what happens. There are two opportunities here. This is the encounter, the delay of 20 seconds. With the delay of 20 seconds, what I told you about. Yes, it went back to to the first stage of the exploit, which is a very good feature of the Metasploit framework, that it supports and make stage payload use very simple. First, it gets a code to the other computer which reserves enough memory for us, and then a TCP connection is sent back to a certain address, and then we'll just suck in the real shell code. 748,032 bytes must be inserted, which is very realistic, beyond any reality. So we have a stage 1, 299 in length. It read this couple of hundred of thousands of bytes, and they started to work. Metasploit, very good gadget. A couple of words. I will just install them to the Windows host, to every one of them, and this gadget pushes a shellcode into the affected process, which is a portable executable loader. DLL file is pulled through the network, which is then injected into the process memory area, then performs those steps which normally are performed by the Windows. So DLL is loaded into the process, and this DLL gives an extendable surface for the attacker. It won't touch the Winchester, not even a single time. And the whole communication is done in SSL, with the exception of sending the first couple of hundred of bytes. It's difficult to manipulate an SSL process, so the whole process is not checked, so we can really just get our foot in. It's on the DVD, a map called Real Gun, and with this map called Real Gun, and this is the best measure of the capability of this device. With this you can achieve that the Windows UPIT can use any DLL which are there, or yours DLL which you uploaded. So any method can be called from this Metasploit. You can issue it from the Metasploit, and there is no trace, with the exception of a couple of hundred of bytes of data traffic. I must stop now. Anybody should be interested in more information, please come to me. Thank you very much for your attention, because we are running behind schedule. Thank you.
Ajándékozom kapsz privátba.